Okay, so now we are going to look at square root of non-perfect squares, and we looked at perfect squares and guessing those values. But let's say we have a number like this, 3200. Now we know 2500 is a perfect square, we know 3600 is a perfect square, so we know this is not a perfect square. Okay, so we had done this number, a number close enough to it last time, and we know that this is 56 square, close to 56 square. Yeah, so you can do 56 square, 57 square, you can find out it's in between those two. That we'll look at later. Yeah, so right now let's say you know what is the closest square for it. So that closest square 56 square gives you 3136. So how far is this from here? This is 64 more from this perfect square. And so what you do is you take 64 and you divide it by 2 times 56, and that gives you 0.57. So if you add this 0.57 to your 56.57, that's supposed to be a close enough square root of 3200. If you square it, you get it's 3200.16. Now question is, why does this method work? And so why this method works is that you are actually finding the square root of 3200. So 3200 is the 3136, which was a perfect square, plus 64 square root of that, right? So 3136 itself is 56 square. So 56 square plus 64, half of that. Yeah. So if I remove 56, it will go into square root, and get cancelled, and then 56 will be there. Okay. So and then you have 1 inside, 1 plus 64 by 56, which I want to take a square root of, right? So this is the binomial expansion, 1 plus a to the power of half, where a is a small number. So if a is a small number, then I can approximate this as that 1 plus half of this a. Now if I multiply 56 throughout, I get 56 whole number. Half of 56, one of the squares will get cancelled with 56. So 1 plus 64 by 2 times 56. So that's basically what's giving me this and why this method works. So if you remember what a binomial expansion is, you are getting 1 plus a to the power of half is 1 plus half of a minus 1/4 of a square, and so on. So we are ignoring the other terms. The first term itself will give us a reasonably good approximation, as you can see.